Geometry notes, section 1.3. Some more vocabulary, all of chapter 1. Midpoint is something you might already know. It's a point that divides the segment into two congruent segments, but now we're using the word midpoint geometrically with the words congruent that we learned in section 1.2 and the word segment that we learned in section 1.1. A point that divides the segment into two congruent segments. Segment bisector, almost the same, a little bit different, but a segment bisector can be a point, it can be a ray, it can be a line, it can be a segment, or it can be a plane that intersects the segment at its midpoint. So you have a midpoint of the segment, and then a segment bisector is what's causing that to split. Is it a point, a ray, a line, a segment, or a plane? A quick diagram of that. Here is a segment. I'll put that in blue. Here's your original segment. Go ahead and draw a midpoint in the middle of your segment. And the way that we know that that's in the middle of the segment, in your notes, in your tests, in your book, they'll put little red, we call them just tick marks, little red tick marks. If there's two matching tick marks, it means congruent. So we know that this half exactly is the same size as this half, which means that's a midpoint. As is, it's a midpoint. But a segment bisector could be that point. You could, if you wanted to, you could put a ray through there. Now that's a segment bisector. It could be a line that went through it. It could be a segment that went through it. It could actually be a plane that cuts through it. Okay, your plane could cut through your segment. That's a terrible drawing of a plane. Let me see if I can get that a little bit better. So your plane, if you picture a piece of paper slicing through a stick, a pencil, that would be a segment bisector. Take a look at this. Draw the kite if you want to, or even if you don't draw the entire kite, at least draw Y to V to X to W back to Y again. Draw the outline of the kite. And also draw the stripes through the middle of the kite. You need both, the segments through the middle of the kite. It says segment YX, write that down. Bisect segment VW. Segment YX, so you see that. Bisect segment VW. Go ahead and get maybe a thicker marker up here or a highlighter. Segment YX. So this segment is going to perfectly cut in half segment VW, and that's going to happen right here at point T. The measure of segment VT, remember we say the measure of segment VT, equals 39.9. Find the measure of VW. Says first use the definition of a midpoint. Definition of midpoint says that it cuts it in half, which means if VT equals 39.9, then so does the measure of segment TW, has to also equal 39.9. And use the segment addition postulate, which we learned in a previous lesson. Segment addition postulate says if you took two little segments and put them together, you'd make one big segment. Here would be an example. Maybe use a calculator. Don't just throw that together in your head. Just save you from common mistakes or simple mistakes. Makes it look like you don't know the math or the geometry, but really it was just a calculating error. 79.8. That's how you would answer it in algebra. In geometry, how are you going to answer that? You're going to answer it as the measure of segment VW equals 79.8 centimeters. Tell me the full answer. The measure of segment VW equals 79.8 centimeters. Okay, next up, Point S is the midpoint of segment BG. Find the length of measure BS. And when we're talking about a segment, we use a bar. When we're talking about length or distance, we don't. Go ahead and draw that. Here's where the algebra comes in. Okay, when you're done drawing it, start it up again. Find the length of BS. We know that S is the midpoint. Well, midpoint divides it into two congruent segments. Congruent means equal. If congruent is equal, then we know that the measure from B to S has to be equal to the measure from S to G. Once they're set up equal like that, you can do the math, solve it, put your x's on one side of the equation, put your numbers on the other side of the equation. 4x minus 3x is 1x. Of course, you would never write 1x. You would just write x, and 3 plus 1 is 4. There's your algebra problem, but it's not an algebra problem. It's a geometry problem. Go back and ask the question. Find the length of the measure of segment BS. So you're going to say the measure of segment BS equals 4 times 4 minus 1, which is 15. How do you know if you got it right or not? Just like this. 3 times 4 is 12. 12 plus 3 is also 15. You can do a quick check to make sure you got it right. Next, identify the segment bisector of segment PQ. This time it says identify. It doesn't say find or find the length. Identify. Go ahead and draw it. Make sure you have this in your notes. As you can see, point M is the midpoint. You can put tick marks here to show that segment PM is congruent to segment MQ because it says it's a segment bisector. But then you actually have to identify that it is a ray that starts at M and goes through N. So MN is the segment bisector. Another one, here's a drawing. Go ahead and draw it. Point PMQ. Draw a line through it. You're going to put your tick marks on there. Segment PM is congruent to segment MQ, otherwise we don't know that M is in the middle. Okay, we know that it's a line, but we don't have 2 points to name that line. You cannot name it line MH. This H is not a point. Line H, you must use a lowercase h. I use a little bit of a cursive H to make it look italicized like this. But when you name a line by a single letter on the outside of it, you have to actually write the word line. You don't just put an H there. So identify the bisector is line H. Moving on to the midpoint formula. The midpoint formula, don't write this down yet. It's on there somewhere. For some reason it's not showing up. But I guess I can just write it over the top. The midpoint formula looks like this. It's parentheses. X little 1 plus x little 2. Notice that's not powers. That's just first x, second x. Cut it in half. Y1 plus y2. Cut it in half. With parentheses and a comma. Parentheses and a comma get in that because a midpoint is a point. It's going to have an x value. It's going to have a y value. Now those of you that are pretty sharp, maybe recognize that instead of looking like a whole jumbled, bumbled mess, it's just the average. You got two numbers, add them up, cut it in half. You get your average. You get a 70 on one test, a 90 on another test, you add them up, cut it in half, you average an 80%. Then do the same thing for the y's. A midpoint is a middle. This is when we're talking about a full graph, not just a number line. If you have an XY axis and we're looking for a midpoint of a segment. Now we have to use a midpoint formula because we got to find halfway between the x's and halfway between the y's. We'll try it with this question. Go ahead and pause it if you need to. The endpoints of segment SR, or RS, are at point R, 1, -3, and at point S, 4, 2. Find the coordinates of the midpoint M. We're looking for the coordinates of M. Remember, anytime you're doing these, that the x comes first. And here's why we call it x1, because there are two different x's, x2. This is the first y, this is the second y. If we follow the formula perfectly, we would take x1, which is 1, add it to 4, cut it in half, comma. -3, add it to 2, cut it in half. 1 plus 4 is 5. If you cut 5 in half, you get 2.5. -3 plus 2 is -1. If you cut -1 in half, you get -0.5. With parentheses and a comma is the proper answer for a midpoint. Now in this choice, I chose to use decimals. You don't have to use decimals. Actually, most of the time I won't have you use decimals because fractions are more accurate, but you are allowed to call it 2.5 and -1/2. But you also are allowed to call it 5/2 and -1/2. Improper fraction, mixed fraction, or decimal in this case are all correct answers. But without the parentheses and the comma, I'm marking it wrong. You could do all the math right, but without parentheses and a comma, because coordinates always have parentheses and a comma when they're properly written. Let's try it again. But look at the difference in how this is written. Go ahead and read through it, pause this, and write it down. Midpoint of segment JK is M at 2, 1. One endpoint is J. Find the coordinates of the other endpoint, K. Pause it to write this down, but then go ahead and draw a segment. We're going from J to K. The midpoint is M. Pardon that bell. And our J is from 1 to 4. Our M is from 2 to 1. And we don't know what K is. There's a better way to do this than to mathematically plug it into the formula and work it backwards. The better way to do this is to say, all right, I'm going to start with J at 1, 4. I know that M is in the middle at 2, 1. How do I get to K at the final answer? Well, you know 2 is in the middle. It's the midpoint. So if I go from 1 up to 2, I added a point. 1 plus 1 is 2. 2 plus 1 is 3. It makes sense that 2 is halfway between 2 and 1. How did I get from 4 down to 1? 3, 2, 1. I subtracted 3. So if you subtract 3 more, 1 minus 3 is -2. You may need to rewind that and do it again because in the past you've done midpoint, but you haven't done endpoint when given a midpoint. So if you're looking back at this, does it make sense? 1 plus 3 is 4. Cut it in half, you get 2. 4 plus -2 is 2. Cut that in half, you get 1. How did I get from one to the other? Just count it. Actually use your fingers or add it, subtract it on the side like I did. So it would be a lot easier than graphing it, and it would be much easier than plugging it into the whole entire formula. Midpoint formula again. These are two that you can try on your own. The endpoints of segment AL, and this time you want the coordinates of endpoint R. If you want to try them, go ahead and try them, pause it, and practice it yourself without looking at the other one. If you're good, you can move on. The distance formula also goes with midpoint formula. Distance formula is used to compute the distance between 2 points, but again, it has to be in a coordinate plane. It's not just on a number line, it's the distance between 2 points in a coordinate plane. This is what your distance formula looks like. Pause it and write it down. Make sure you get that square root in there. Notice the difference between these twos are exponents. Those twos are subscripts. Just there's 2 x's, there's 2 y's, so you're subtracting them. Write that down. You don't necessarily have to memorize that. You might accidentally memorize it if we use it enough. Here's an example. You have 5 and 2 and 8 and -2. You first might want to label them as x1, y1. Careful, don't label that x2, y2. It's x1 and y1. And then here you have x2 and y2. It says go ahead and take the second x, 8 minus 5, and square it. Plus your second y, -2. Subtract your first y and square it. I will take the square root of this, but not yet. Not yet I'm going to let you take the square root because we don't want decimals. You can get irrational decimals if you take the square root right away. And I don't want you to do these separately. I'm begging you, don't take 8 minus 5 and make it 3, and then 3 squared, and then make it 9, and then over here take -2 minus 2 and make it -4, and then square it and make it 16, and then take your 9 and your 16 and add them together, and then when you're done, finally take the square root. This should be a 2-step problem. Step number 1, after you've written it down, is to just type it into your calculator. I want you to just turn it on, hit your parenthesis, 8 subtract 5, parentheses squared, plus parentheses -2, make sure you use your negative button down here, not your subtraction, -2, parentheses squared. That's your 1-step solving. All you have to do is hit equals 25. It saves you from making any mistakes. You don't want to accidentally take 8 minus 5 as 2. Or -2 minus 2 is 0. I've seen people do that. So you get 25 for your distance, but that's not the actual distance because we have yet to take the square root of everything. After you find out the whole number 25, then you square root the 25 and find out that the distance is 5. So the distance is 5. Final answer. Let's try another one. Go ahead and write this one down. Do me a favor. Write it down, pause my video, and do it yourself the way that I taught you with a calculator and see if you come out to the same answer. Pause it. This time you should get 40, but it's not actually 40. Go back and put your square root. It's the square root of 40. Why didn't I have you type that into your calculator with the square root? Because if you type it in with the square root, you get an irrational decimal. What's irrational about that? It's 6.32455532. You don't want a decimal that doesn't terminate. So your answer here is square root of 40. If you remember how to break that down, that does break down into 8 and 5, or 4 and 2, or you could have broken it down into 4 and 10. The square root of 4 is 2. The square root of 10 is left over. That would be the perfect answer. This is an okay answer. 6.3, not an okay answer. Final problem on a graph. It's all graphed out for you. You can just watch and follow along, or you can put this in your notes and just draw your graph and label your spots. Between -4 and 5 is your first point. 2 and -2 is your second point. You're trying to find the midpoint between those, which is nearly impossible, because it's not straight horizontal or straight vertical. So when it's this difficult to find, you're going to use the distance formula. Well, the distance formula will actually help you find the distance between the two x's, -4 minus 2. But notice this time I went x1 minus x2. You're going to get the same answer. Whether you measure from here to here on x or here to here, it better be the same distance. And then you're going to measure, I'll put this one in red, from 5 minus -2 squared. Put that into your calculator. You might get, wait, am I asking? Yeah. For the distance between those two, we've got to find the distance, -4 minus 2. That goes from here to here. And then you square it. Let's just call that A. The next one goes from 5 down to -2. There's that distance. Let's just call that distance B. When you calculate that out, it will give you this final distance in purple. We'll call that C. Well, if you look at the distance formula and compare it to over there, you have A squared plus B squared equals, I should do that in purple, C squared. The Pythagorean theorem and the distance formula on a coordinate plane are the same. Whether you find the distance formula using a formula or you found the distance using the Pythagorean theorem, you're going to get the same answer if you remember or knew the Pythagorean theorem. What do you get when you type that all out? Should be the square root of 85, which again is irrational, so you won't put it as a decimal. All right, there's the end of your chapter 1.3 notes. Good luck on your assignment, and again, use your calculator, please. Save yourself from making mistakes.